Hi friends, let us start a new topic on linear algebra, which is rank and inverse of matrices. And for rank and matrix, we have to understand what is the adjoint. Adjoint means if we find the cofactor matrix and then its transpose, it is called the adjoint. That means transpose of cofactor matrix is the adjoint. Next, what is inverse? A, B, an enclosure matrix, and if there exists an enclosure matrix B such that AB equal to BA equal to I, then B is called the inverse of A. Meaning is that if we have a matrix A, then we want to find the inverse matrix. No, so if there exists a matrix B and this condition satisfied means A multiplied by B or B multiplied by A, both are equal to I and they are also equal, then it is called then B is called the inverse of A. For an example, you can see A is a matrix which is 0 minus 1 minus 1 0, and B is a matrix also 0 minus 1 minus 1 0. Now B is inverse of A if and only if AB equal to B equal to I. Now AB equal to I, also B equal to I, so we can say that B is inverse of A. That means A inverse is equal to minus 1 0 minus 1 minus 1 and 0. Now a theorem. Let A be any square matrix. So A be any square matrix. Okay, then A into adjoint of A or adjoint of A into A, which is equal to determinant of A into identity of N. Okay, if determinant of A is non-zero, then you can say that A adjoint of A equal to determinant of A. So that means if this in here and A here, so A inverse is equal to adjoint of A by determinant of A. So this is a formula to finding the inverse. You have to find first of all adjoint of A and find the determinant of A. Then adjoint of A by determinant of A is our A inverse. The condition is the determinant of A is non-zero. Now inverse of 2 cross 2 matrix. Normally for a arbitrary matrix A, B, C, D, then adjoint of A, we know for 2 cross 2 matrix, how can we find adjoint? Just reverse the diagonal elements, so D and A, and just multiply by negative or change the sign of this, means minus A and minus B, minus A and minus B, and this is our adjoint, and determinant is AD minus CB, and which is if it is non-zero, then A inverse is equal to 1 by AD minus BC into D minus B minus C minus A. Okay, now what is the row echelon or echelon from? So all the 0 row at the bottom of the matrix, that means all 0 row at the bottom of the matrix means if there is any row which is 0, then it should be in lower in the bottom. Okay, here you can see for this example the 0 is in the bottom. Next, the leading coefficient. The leading coefficient of a non-zero row is always to the right of the leading coefficient of the previous row. Means the leading coefficient of first row is this. Leading means the first coefficient, first non-zero coefficient, you can say. First non-zero element, first in the row, first non-zero element. Okay. Now this is in this position. Now for the next row, the leading element should be in the right. You can see this is the in right of this leading element. Am I right? Leading coefficient. Okay, and this leading coefficient is called pivot. The first non-zero element is also called the pivot. Okay, you can take an example. This is a row echelon or echelon form. Why? Because there is a 0 row and which is in bottom, and this is your first coefficient, non-zero coefficient, and for the second non-zero coefficient is right in this, and this is only two condition that is held, so that's why it is a row echelon form. Now there is a advance which is row reduced echelon form. What is row reduced echelon form? Row reduced echelon form says that it is a row echelon form with two additional condition, means the first two condition is hold for row equivalent form. Row reduced equivalent form, it is also row equivalent form, so two condition is already hold, but you have to add some extra condition like pivot must be 1. Pivot means the first element it is must be 1, and first non-zero coefficient of first row is not 1, and secondly each column that contains pivot uh, that contains pivot has zero entries everywhere else, means this is this means that this is your zero, this is your pivot. So and the another all the entries of this row in this column should be 0. It is our this is one to say. Okay, now you can see here like an example. The example says that change to row equivalent form. Change to row equivalent form. A matrix A is 0, 2, 3, 1, 2, 1, 2, minus 1, 0, 5, 2, 0, 1, 2, minus 1. Now, since here is 1, so we can't say it is row reduced. Why? Because there is need a element which is 1, because pivot should be 1. So we can change this to row by applying some operation. What? R1 by R2 means this row is swipe. So 1, 2, minus 1, 0, 5 is in upper row, and middle row is 0, 2, 3, 1, 2, 0, 2, 3, 1, 2. Now for the next operation, if R3 dash means in the last row, the operation is R3 minus 2 R1, means this minus 2 into this. So sorry, 2 R1, 2, this minus 2 into this. So this is 0, because we need without pivot the all elements should be 0, so all the element is 0, so we get this actually. Now this is also we have to do another operation for this element, and which is also 0. Now you can see now why we did this operation, because we know for row equivalent form, if it is the leading coefficient, then it should be the leading coefficient of the third row in the right of the leading coefficient, so it should be 0. So that's why we're doing this operation. Okay, now it is row reduced. Why? If there is a 0 row which is in the bottom, there is no 0 row, so you don't have to worry about it. Now second condition was the leading coefficient of the next row is in the right. It is true, so it is row equivalent form. But after row equivalent form, you have to see two condition more, like it is a pivot, and pivot should be 1. Okay, and another is 0. So all the condition are done, so that's why it is a row reduced equivalent form. And rank of A is 3. Why? Because number of non-zero row is called the rank, and number of non-zero row is here 3, so that's why it is rank of 3. So definition of rank of matrix, if you want to find the definition is number of non-zero row in a equivalent form of a matrix, not a row equivalent form only, not row reduced, just only if you find the row equivalent form, then the number of non-zero row is called the rank. Okay, now some properties of this rank. First properties, if P and Q are non-singular matrix, that is determinant of P and determinant of Q is non-zero, then A is a square matrix, then rank of PA equal to rank of QA equal to rank of A. Okay, A can be any matrix, P and Q non-singular matrix. Then if P, Q, R is non-singular matrix, then also R into A is also equal to rank of A. That rank of R equal to rank of A. Now there is some properties more, like rank of AB is A and B is matrix, then rank of AB is less than or equal to minimum of rank of A comma rank of B. Then rank of A and rank of A transpose are same. Then A is invertible if and only if rank of A equal to n. The rank of A n means there is no non-zero row. That means determinant of A is non-zero actually. That is invertible. or you can say if determinant is non-zero, then rank of A equal to n, since it is if and only if condition. For a square matrix A and B, we say rank of AB is less than or greater than or equal to rank of A plus rank of B minus 1. So by these and this condition, we can say that rank of AB is greater than from this and less than from this. So rank of AB, rank of A plus rank of B minus 1 is less than or equal to rank of A B less than or equal to minimum of rank of A comma rank of B. And also rank of A plus B is less than or equal to rank of A plus rank of B, rank of A minus B is greater than or equal to rank of A minus rank of B, and rank of A transpose B equal to rank of A equal to rank of A transpose. Okay, so this is our today's lecture, and in the next lecture we will go for the system of linear equation. Thank you.